All right, for our unit test, we're going to take a little bit different of a look at this preview than we normally do. It is especially chunky. So what I'm going to do in each of the sections is I'm going to choose a problem or two that I think best represent that section. That I'm going to work through with you to get, again, let's get some good examples, but I'm going to leave some of these for you to be able to do on your own. I'm going to post the entire preview key online and we'll have it in class, but I'm not going to do every single question on here like we typically do. So with that in mind, let's jump on in. Oh, and I'll mention one other thing. The test itself is going to have somewhere in the ballpark of 25 to 26 questions, so it's not going to be anywhere near as chunky as this preview is either. Okay, without further delay, simplifying expressions. Notice pluses and minuses in the middle. We are not boxing these. We are not foiling these. They are not products like they are down here. So up here, I'm just going to be combining like terms. The plus, I literally just start putting the like terms together. There's nothing to think about. The minus, there's a little more work because that negative is going to distribute through to every single one of my terms in that second set of parentheses, changing their signs. Once that's done, now I need to put the like terms together. Okay, no more messing with the exponents. We're just 8 of these plus 7 of these gives me 15 of these. And now I got the single x squared term. Negative 7 plus 3 is negative 4x. Keep it simple and keep it right. Okay? So again, simplify. If we see stuff in between the parentheses, we're just combining like terms. You're like, okay, Harty, we get it already. As we get a little further down, I'm not going to do 4 and 5 because we have seen so many boxes that are 2 by 2 over the past 2 weeks here. We shouldn't need to play that game anymore. But the other two types I do want to chat about. Okay, remembering that there's always an exponent on there. If there's just one term, I can go ahead and distribute. Now again, we're multiplying coefficients. We're adding exponents. Multiply coefficients. Add exponents. Multiply coefficients. And there are no other exponents to add in. Okay? There I have to multiply. There's nothing separating the 5p from the parentheses. Or a problem like 9, where, again, nothing in between. I'm going to do a big old box. Now, could I distribute the m through and then distribute the 8 through? If you want to go that route, you feel perfectly free. I am more for organization and making sure I don't miss any of those things. So here, add my exponents, multiply my coefficients. And I'm going to do that all the way through. Once the box is filled, if I start in the upper left corner, that's where my largest degree will be. And again, at this point, the m squared isn't changing. It's just negative 4 plus 64, which is 60. Negative 32 and negative 5. Just adding and subtracting to get to that final polynomial. Okay, this first page of this and the first page of the test 2, ones like this should be the layup questions. These should be the ones that you build your grade and get it way up there with. But you've got to make sure that you're being careful with those. Okay. So we flip over, sketch the graph of the function, find the domain and range, tell the end behavior. Okay. Let's go ahead and get this typed in. Okay, I can take a peek or see when I get here. I've got a parabola. Okay, I see that. Now here, since we're just doing a basic sketch, I don't need to go in and find all the intercepts and stuff like that. I'm going to go ahead and just use my chart to get some points so I can make a pretty decent sketch of this guy. Okay, so I get that in. So, find the domain and range. Okay, domain, again, x values left to right. Well, this is extending out forever to the left, extending and expanding out forever to the right. So my domain is infinite. My range is my y values, bottom to top. Okay, I see it goes up forever, so I've got the positive infinity, but it doesn't go down forever. It only goes down to here. And since we're looking at y values, the y value right here is -1. Okay, so I have to watch out for those things. But usually arrows are going to get me towards infinity. And then the end behavior, it's been a little while. Remember with my x's, one's heading to negative, one's heading to positive. And we talked about this a lot when we were doing these. Maybe I labeled my picture too. But here's what this is saying. As x goes to the left, okay, I find my left arrow. What direction is it going? Well, it's going up. What does that mean? Well, remember, f of x is just a fancy way of saying y. So if it's going up, when we're dealing with y, we're moving towards positive infinity. So that's what we put in here. Y goes up as x goes left. But I have to use the infinities. I can't use the words up and left. Okay? And then the same thing here. As x goes to positive infinity to the right, where's my arrow going? It's going up. So when y is up, we're heading towards positive infinity. Okay? And that's how that works. Now we're going to do one more here. We're going to do 11 as well. The big thing with these is just going to be, again, take the extras that we don't do together and practice. Make sure that you're an expert in the area, or at least that you're a little more comfortable, maybe, than you might be right now. So I move this over a bit. There we go. And now I look and I go, all right, negative x to the third plus 2x squared. Ah! That wasn't good. Forgot to hit my right arrow to get down out of there. All right, let's try this again. Let's get a look at the picture first. There's my snaky snake. There we go. Graphed in there. There we go. And again, I'm going to start looking and going, okay, so let's see. Domain, left to right. Forever to the left, forever to the right. So that's infinite. What about my range with my y's? Forever up, forever down. All right, can handle that. For my end behavior, my x's are always the same. I'm kind of using the last one as my example here. So I'm like, okay, as x goes to the left, and my arrow going to the left, which direction are we going? Up towards positive infinity. And then I switch and I go, okay, now as x is going to the right, find my arrow that's further to the right. Which direction is it going? It's going down. Well, down, when we're talking about y, is toward negative infinity. So circle those. Kind of see how they work. And make sure that you're not getting yourself bound into a corner here that you can't get out of because you didn't practice. Okay, a couple more to practice and to be able to ask some questions on. So let's see what else we got here. Evaluate the function. Okay, evaluate just means take that value they give you, and everywhere that you see that variable, plug it in. Okay, this is just a label. I'm not plugging in and solving anything here. I always want to use parentheses, especially when there's exponents involved. I could type this whole thing into the calculator, or I can kind of crank it out manually like I am here. 9 minus 21 is negative 12, plus 13 is 1. So evaluate means solve. Get a number at the end. because I've got to make sure that works out that way. So I do that for the next one. Write each polynomial in standard form and then name the polynomial by degree and number of terms. Okay? Standard form. Biggest exponent to least. Biggest degree to least. 3, 2, 1. Okay? Name the polynomial by degree. 3 is a cubic. 2 is a quadratic. 1 is linear. Like, wait, what is that again? 1 is linear. 2 is quadratic. And 3, like it is in this case, is cubic. I wouldn't ask you anything about that. Then the number of terms. 1, 2, 3 terms is a trinomial. 2 terms is a binomial, like a bicycle. 1 term is a monomial, mono meaning 1. And that's what we're looking for there. Nothing to calculate, just got to reorder some things, maybe. Now our functions. 19. Find f times g of a. Okay, so what am I being asked? I'm being asked to take f, which is a squared minus 5a, and multiply it times g, which is 4a minus 3. Now, we have and will be seeing a ton of these. So you're like, I just do a box on that? I don't have to plug a into... No, this isn't a composition. It's a little dot. When we get to 22, which we're doing together, that'll be a composition. So, just like we've done on our other boxes, multiply coefficients, add exponents. Be careful not to lose a variable anywhere. Box that out following my rules. And then just write my answer from the largest degree. To the least. Okay, so the critical part here, I'm hoping you're kind of noticing here at the start, is looking for whatever symbol's in the middle. Okay, g plus f, combine like terms. Don't do anything fancy. Even on number 20, the next one that we're going to do, okay, g minus h of a. I literally would write all this out. So g of a, 4a plus 4, minus h of a minus 2. Kicker here, just like we did on that problem on the very front of the review. The negative, the minus, distributes through. Negative a, positive 2, and don't stop. We still have like terms to combine. 4a minus 1a is 3a. Notice I'm not messing with the a's at all. Just the coefficients. 4 plus 2 is 6. There's my g minus h. Okay, but I got to remember to distribute the negative, and you've got to watch the order here. They might not always be in order top to bottom. It might say h minus a instead. You've got to pay attention to detail.